This is at the beginning of the school year, school districts implemented a new physical fitness program. A student project involves monitoring how long it takes 11th graders to run a mile. The following data were taken mid-year, so this is the middle of the year. What is the estimate of the population mean time it currently takes 11th graders to run a mile based on the following data, these are in minutes, from a random sample of 10 students. So we've got a sample here. We don't have the entire population. We just have a random sample of 11th grade students, and we have 10 of them. Well, how do we find the mean? Right? We're just going to take the sum of the values. I'm going to call them the numbers. We're going to divide that by n, right? However many we have in the sample. Okay. And if you do that, you get a mean of 7.9. Everybody knows how to find the mean, right? I don't need to show y'all how to add those up and divide by 10, right? Okay. So that one's pretty simple. That is an estimate of the population mean, though. Okay, we would use that because our random sample should mimic the entire population. So we can estimate that the mean of the entire 11th grade class would be 7.9 minutes. So almost 8 minutes to run 1 mile. Now, B says the students doing the project collected 50 random samples of 10 students each. So the same thing, they did another 10 students, found the mean. They done another 10 students, found the mean. Another 10, another 10, another 10, another 10, until they done it 50 times. And they calculated the sample means. The standard deviation of their distribution of 50 sample means was 0.6 of a minute. Based on this standard deviation, what is the margin of error for their sample mean estimate? Now, how do you find the sample, or how do you find the margin of error for the sample means? Anybody know? Anybody remember? Since we have the standard deviation, all you have to do is say 2 times the standard deviation, and that will give you the margin of error, okay, which is 1.2 minutes, okay. So if you're given the standard deviation, all you have to do is multiply by 2. Now, so basically you would say that the margin of error is twice the standard deviation. Because the standard deviation, if you think about it, a standard deviation is only talking about one standard deviation would be above the mean. Okay? So you would do 2 times that to give it to you on the other side of the mean. And that would be your margin of error. Now let's go to C. It says, interpret the margin of error you found in B in the context of this problem. Okay, so what we would say is 7.9, which is the mean, minus 1.2, and 7.9 plus the margin of error. And this would give us, oh, that's not right, that's a 7, so 6.7. And this would be 9.1. Okay. So our plausible values for the population mean, let me write that, plausible values of population mean, it's going to range between 6.7 and 9.1. So those would be a good estimate of finding the entire population's mean. Okay, it would be somewhere in between 6.7 and 9.1. Okay. Everybody understand what's going on there? Anybody got any questions about that? Okay.